Hello, hello.
So, can you hear me? Yes, sir. Okay. Sir, 1 second. Yeah, sure. Sir.
Good morning, everyone. So I am happy to invite you all the SAE lecture meeting series, and this is SAEISS Trichy division, and we have Professor Dr. Raju Dandu, Professor and Director, Bulk Solids Innovation Center, Kansas State University, USA, and we have the lecture on convergence of disruptive technology-driven trends transforming the auto industry. Professor Raju Dandu is a professor of mechanical engineering technology and director of Kansas State University, Bulk Solids Innovation Center. He received PhD in mechanical engineering from North Dakota State University, Fargo, North Dakota. Diploma engineer from Slovak Technical University in thermal and nuclear power engineering, and diploma in automobile engineering from Andhra Polytechnic, Kakinada. And he served as graduate program director in Kansas State University, Salina campus. His research interests are applied research in providing solution to industry in the areas of storage, handling, and pneumatic conveying of dry bulk solids, systems, and product design. And serving as chair of ETAC, that is Engineering Technology Accreditation, served on ABET governance as member of the Board of Delegates and member of ASME, American Society of Mechanical Engineering, on Engineering Education, Board of Directors of American Society for Engineering Education, and Board of Directors of Savannah Area Unity Way. He provided consulting services in product design, manufacturing, industrial automation, patent filing, grant writing, startup business development, product CE certification, reliability, centered maintenance, and training industry workforce. And currently, he works with a team of industry experts at Bulk Solids Innovation Center, the only university center facility and staff in North America dedicated to improving technology and knowledge of power and bulk solids handling various industries. Dr. Dandu also teaches undergraduate and graduate courses such as multidisciplinary capstone design, modeling and simulation, manufacturing, test and evaluation, application of autonomous and augmented reality, and thought, the industry intensity of things, and data mining. So we welcome you, sir, for this wonderful event organized by SAEINDIA Southern Section, Mr. Application.
Thank you very much for your wonderful introduction. First and foremost, I'm very, humbled and honored to be, associated with the NIT for a long time through Dr. Bhuvan Sekharan, and he and me, we were classmates. I also had the opportunity to come to Tamil Nadu and work at the Welding Research Institute, but my path has taken, my journey has been a little bit different. And involving with Dr. Bhuvan Sekharan and with your faculty that I have been with, Dr. Sankarnaran, that, Shivasham Mogam and Bala, and, several people, it has been a privilege, and it has been a long time overdue to coming to Trichy, and I really appreciate, hosting me here. Thank you very much. Just I was telling Dr. Shivasham Mogam that it is my fault. I have, because I put him on the hotspot, changing the, the timelines, this and that. So they call it as a project people. So that means you don't stay put with what you have said, and you start changing and changing. That's what I told him. Even though I left India, I haven't changed. I'm changing every second. But anyhow, so in this presentation, just I'm going to give you the overview of the current emerging technologies, what is happening, how things are happening, and how fast they are happening. And first and foremost, the younger generation, you are the inspiration for us, and we strongly believe you are the torch holder for the future. And it is always exciting and inspiring for me to work with the young people. That has been, even though I have a gray hair, working with the young people, they makes me look like a young man. So still that, And also, just I would like to tell you that, in this presentation and some of the information that, what you see, some of the images, they have been, how do you say, cut and paste, that, they are not mine, that I have borrowed those ones, but you will see the source of some of those. So that way that you will know that, this information that, I try to find out also on the websites and other places. So I don't want to give you the wrong information that is my work. So I want you to be aware of that. So again, in this presentation, basically, as you can see that, you have the convergence. So when we talk about all these emerging technologies, especially that, in the manufacturing side, so changing so fast, okay? But still the manufacturing is the economic backbone of any country. The fundamentals of the manufacturing still it will remain when we try to use these emerging technologies. So that means we are leveraging the information technology, which is previously available, but it hasn't been to the full extent that has been leveraged. So how we want to understand what do we mean by the convergence. Everybody is using now the fancy terms, disruptive technology, and also that you see that in older days we used to call physical system. Nowadays, cyber physical system. It is basically leveraging the existing physical system, and also on top of that the information technology or the emerging technologies. Yeah, can you move to the next one, please? Yeah, so basically that I know most of you are aware of this. You can find the information on the internet and everything, but I would like to that anytime we try to give the workshops and train the industry workforce, they always wanted to know the definition or the functionality of that one, and also the understanding behind that and the application, and they wanted to know how to troubleshoot this. And that's what whenever we try to basically train the workforce, that's what they told. We don't need your questions. We'll find out those ones later on, because they have day-to-day applications which they have to deal with, because the production, if you have the production, you make money. If you don't have the production, you don't make money. So that's why that we see that that I put it. What do you mean by convergence? And also what are those disruptive technologies? There are so many of those technologies. So that is the case, which technology is a good candidate for certain area. Business workflow, it may have a different application, manufacturing, or discrete, or the process industries, or you take different industries, aviation industry, automotive industry, because these are all have different communication protocols. And how do we basically try to implement these disruptive technologies? That is also going to be a challenge. And what are the drivers here? What is driving this? Why do we need to use that? So and afterwards, that basically that I will show some of the examples that where this disruptive technology has been. Again, you're all familiar with that and the challenges. The technology is one thing. Currently, we are doing some projects. Still, that we have problems even to access the data from a company to the student design project team. So initially, what we think is, the data is just, it is a data file, Excel or image file or whatever it is we can import. But because of the security reasons, we have lots of issues. On the surface, it looks good, but it is in the detail. So and also just what is the future for the industry and everything that how do we So here basically this is the reason that I'm showing this one is, as you have seen from the 18th century to now, that you see the progress of the industrial revolution. Now we have industry 4.0, and also we are talking about industry 5.0. So the beauty is, especially for the younger generation, think about it. If it hasn't happened yesterday, it is going to happen tomorrow. So that we should embrace these technologies. We try to leverage those ones, and we try to basically apply to improve the functionality, or the flexibility, ease of use, all those things. That's why, as you can see, that how we progress through centuries of this. That means, again, bottom line is, if it hasn't happened today, it will happen tomorrow. You yourself, you have seen going through the mobile phone technology. One of the examples that in Africa, we used to. How many of you are familiar with the rotary phones? Did you use the rotary phones when you dial the numbers? So you see now, it's not the part of the current generation. I mean, in Africa, actually, when they wanted to lay down these telephone lines, the infrastructure, it has been very difficult. And also, it is cattle, Indians. So luckily, when the mobile phones they came, basically they were able to skip the one generation of the technology completely. See, some countries, if you look at the Western countries, they have gradually gone from one technology to other to the next. But in some countries now, we are able to skip generation of the technology. So that is the beauty that So okay, so can you? Okay, yeah. Okay. This is what I want to share. This one is the upper left-hand corner. What you are seeing is that is the the electric car designed and made by Thomas Edison in 1904. Sometimes I never thought they were electric irons, because when we were going to from coal to still with so many different technologies. But you see, in 1904, that electric iron one, and if you look at the plug-in, right, the same as the plug-in of the electrical car. Also, the extreme right-hand side of the arm, what you are seeing is, we usually use the word turn on the light. But actually speaking, we don't turn on the light. We switch on or off. But when Thomas Edison initially when he designed, olden days it used to be turning and on. Still, the technology is here and there. You have to turn them. So that's why we use that word turn on. And at the lower left-hand corner, what you are seeing is that is the largest tensile testing machine in the world. This one is located in Baltimore at National Institute for Science and Technology. And as you can see, almost 5 megamillions, or that you have almost 500,000 pound force. And this machine, basically, I think maybe 10 times taller than me, or more than that. But it is fascinating, especially if you are a mechanical engineer, that a tensile testing machine, when you look at that one, we see the, room size, maybe, 10 feet or maximum 15 feet or something. But this one is about, that's where East basically they do the calibration for all the different types of force sensors and other things. So I was fascinated, and wherever I go, I always try to show them. And also this one is at University of California, San Diego campus. 10 years back when I was there, as you can see that, when we talk about the emerging technology, actually they were on the forefront. And this one is, it is like a humanoid, you can communicate with that one. But at that time, the only thing is, it was not available is, it cannot recognize the emotions. It cannot recognize the feelings. Now you see that, what was not available in 10 years back, now basically we are that implementing that, even to capture the, nowadays, the new cars, if you're falling asleep, basically it will tell you. It will tell you that, you're falling asleep, you need a coffee break, take a rest, stop. See, that's how basically it is also reading our facial expressions and, telling. So, but you can communicate, and I was excited when I saw that one. Oh. Oh. Sorry. What is it? Can you go? Okay. Sorry about that. Yeah. But here, again, that, we always like to understand, I guess that, always go to the, the foundation, to the source of the information. Even though, nowadays they use a lot of buzzwords. Design for manufacturing, design for sustainability. Again, in the vehicle technology, they use, vehicle to vehicle communication. Now they start, V2X, there are so many X's behind the lots of letters. So here, as you can see, convergence means basically when we have the silos of these technologies are sitting. So basically we want integration of that one and also interaction. It is not only integrating that one, but all these devices, can they communicate? All these technologies, at the end of the day, they have to have a proper communication. Because when you look at the communication protocols, as I mentioned, automotive industry is a different, even though the sensors are more or less the same type of sensor, but the communication protocol is different. You go to the process industry, it is a little bit different. You go to the discrete manufacturing, it is different. So that means, you see, that various is a problem. So with the various technologies, so that if we can basically properly integrate that one, that the interaction, that is the communication, despite all these things we can have. But also, at the end of the day, the convergence of bringing everything to one place, it is basically, that's what the new opportunities, new transformation. See, transformative things, if you carefully look at, for the equation of a force, F is equal to, if you look at, the basic equation in the electrical field, V is equal to I. You see that there are three variables, here are also three variables. Even if you look at the fluid flow, it has exactly three variables. Q is equal to multiplied by the velocity. So if you, similarly, even the heat transfer, if you look at those, there is a analogy between all those things. So if you have a computer software, if you write just for three variables, computer doesn't know whether it is a fluid flow transfer or whether it is, dealing with the electrical things or dealing with the force. Because whatever you define as a variable, that's what it will take. But the same program, same equation can work. So we want to see that, transformative, that sometimes transformative is what we think is, if it is applied in one area, it cannot be applied same normal and same scale in a different area. That is not true. Actually, that can be that, applied just, that As you can see now, because of the convergence of all these things, it basically, we are basically leveraging all these sources of this technology in one place. Here I will show you some example here. You look at the manufacturing sector. Because on the left-hand side, that is the traditional manufacturing. That what you are seeing is, I don't know whether it is legible. I apologize for the font size. That left-hand side at the top, you are seeing order to cash life cycle. That means if you have a manufacturing facility, somebody orders, you make that one, you deliver them. And also asset life cycle management. When you have all kinds of machinery and other things. It is just like a health monitoring companies, equipment and everything. You want to manage this, knowing the life cycle of that one, how many years that machine has a life, and that is, and supply chain. Supply chain is another way. You have seen if somebody sneezes, somebody else will get a fever. That means, when Thailand had floods, and suddenly chip manufacturing stopped. And everybody else, they were not able to buy the chips, and they are not able to basically bring, the complete printed circuit boards and other. So the supply chain is also, if you carefully look at in olden days, you used to buy so many different suppliers, but nowadays manufacturers, they identify a quality supplier, they identify, even they claim their suppliers about. So when you have all those, product life cycle, security now, the new things, in olden days, we never cared about sustainability. We never cared about the climate change now. Now you see you have sustainability, climate change, product life cycle management, and also the circular economy. These are all the buzzwords which are coming. But now, whatever you design, whatever you want to make it, you need to basically think about all those things. It is not anymore a simple design. Now, this is basically what you are trying to do here on the right-hand side, that if you want to make a system smart, see on the left-hand side, these are all these siloed ones, different manufacturing facility it can have. But now, basically, with the emerging technologies and other thing, we are able to converge everything, share the information, and bring that one. So in real time, you are able to share the information, and so that we can make your manufacturing more efficient. And it is not only just the design, from the design to the manufacturing, even decommissioning those things, you can include all these technologies. How the fly you can get the information. Just about it, the same thing, what is happening in the automotive industry. Now we have so many systems, now we are communicating with all these systems. So again, now when we talk about all these things, we always think, oh my God, data analytics, it is a new technology, and data science it is new. Think about it. Even if you are doing the tensile testing, all you do is you have the sensors, you make the measurements, and you collect the data, and you analyze the data, and then based on that one, you are able to, explain the decision-making process you can do. The data mining and data analytics, it is doing exactly this. Example that, as you can see that, let us say this Prof testing machine, I don't know whether it is available in different places. Let us say that in a tensile testing machine, it is used by so many other colleges. So, but the information, whatever you are collecting, is residing only you. But now, that if you communicate with all the other colleges, students are doing the same experiment. Actually, you can collect the data and see what is the variation. If you are following the standard of procedure to do the test, or medical hospital. One major thing, they can have hospitals around the country. They might be treating, cancer or whatever the disease. But that information is only decided only in that physical location, but it is not shared. But now, because of the technology, actually with the group of those people, the information can be shared. Hey, we have a patient that have you had an experience? Yes, we have. This is how we did it. This is how we did it. See, when you share that information, then you will be able to, that's what it is happening in the, level 2 that you can share, or if you have CNC machines, you can have, maybe you are making the same component, 4 or 5 different CNCs, but when you look at the geometric dimension and tolerance, and maybe it is different. So that is the case, same part, same type of machine. So why there is a variation? What is tolerable? So now these new technologies, with the data mining and other things, we should be able to find out the new, it gives some insight. So whether it is automotive industry, whether it is manufacturing or business or whatever it is, now we are looking for the database evidence. So that means what type of new information it is given. That's what it actually we are using. And for a data science, it is the same thing. If you look at the equation of a line, y is equal to mx plus b, it is telling you the trend. It is the same thing. Data mining, that when you use the machine learning or artificial intelligence, you are using the better data set, a clean data set, so to see the trend, to predict something. So that means you have the knowledge. Don't think you don't have the knowledge. Actually, we are marrying the whatever the foundational skills we have. On top of that, we are leveraging. So if somebody tells data science or data mining, don't say oh I don't know. You did the linear regression. You know the equation of a line. If you have taken statistics, exactly the same thing. Whether it be Lean, Six Sigma, or machine learning or artificial intelligence, data science, they are using exactly this. The background is the data. So what we understood about that one? Disruptive technologies, it is basically, from the word itself, it is, it basically throwing off the track from normal life. Some new thing it happens, and suddenly that we get confused or disoriented. But in this case, as you can see, they are actually that leading us to new innovation, to identify new way of leveraging those things, and are the revolutionize the industry. Now, even in India, that if you see that I see that digital gadgets, they are used so much compared to the Western countries. You don't find that. Here I'm amazed to see that because India has talent. India is progressing very aggressively, and in some of the areas it is very advanced. But now that we need to leverage that one, convert it to the business model where we can improve it. That is, So again, as you have seen, it is disruptive now. New markets. Now we have significant universities starting programming, artificial intelligence, machine learning, data science. That suddenly that they popped up like mushrooms. Mushrooms, if it rains today, tomorrow morning you see a harvest of mushrooms. So it is the same thing that you can see. That's what is happening. So if that is the case, now we talked about the convergence, that is the integration and communication that between the devices. And the disruption is basically that using the new information what we have, how we can leverage that now. Especially if we look at the all these technologies, these are all the transformative. It is not exclusive just for the automotive industry. If you look at that one, in daily industry, from education to healthcare to the process industry to any industry, the same technologies can be used. But again, we want to look at what is Internet of Vehicles, smart sensors. Example, human eye is a smart sensor because it is not just a sensor. Human eye is the only thing that is going to see something. But a human eye basically sees something. Basically, it has that it can recognize somebody's face and their feeling and their emotion. If they are angry, immediately they will trigger to the brain. This person is walking towards you with with the angry face, so that means something danger will happen. You better react to that. Either you run or you stand. So see that biological system, they are actually, very, uh, that's what we are trying to do, learn from the biological systems, can we implement those? Because some of the biological systems, they are very intelligent. That's what it is happening in the industry. Then a campus that you have seen, this is what also my dream, because at some point in my life, I will not be able to drive. I don't want to depend on my children. So that, voice activated, I can call the car, will come to the front door, I can hop on, I can tell, okay, take me to the farm. It will take, after I can order the things and they will come home. I don't have to worry about. You see that I'm reducing the dependence. So my son or daughter will not, oh my God, my dad is going to call me again. You know how it is. You are busy with your life. On top of that, you have to take care of one side of the parents, other side of your spouse's parents. Then you think your life is going by parent itself. You don't have time. So that B2B, that is the vehicle-to-vehicle communication. So that means, nowadays already, using the Google, you can share your location and other things. Now basically with vehicles, basically you can share, the information, exactly track where it is. And the B2I, that one is the infrastructure. Down the road, they were telling, there will be smart roads. Actually, already almost 10 years back, Mercedes and BMW, because whenever you have that, middle white lane, for some reason, if you cross from your lane to that white lane, automatically you will see the vibration on your steering. So that it is basically telling you, hey, you are off the road, and you are off the lane. So that means down the road you are going to have, smart roads. Previously we never thought about the smart roads. So that means, down the road you will see that. Now, that is B2B and B2I. Now they use another fancy term, B2X. So that means X means there are zillion variables. So that is another thing, that we need to, be aware of that one. It is the same thing, virtual reality, augmented reality, extended reality. You have those, yeah, I have one. Thank you. So similar way, you have an augmented reality, that especially that, for me, I found compared to the virtual reality, you have to spend a lot more money, a lot more resources, and but with augmented reality, actually it can be applied. We did recently a project for the predictive maintenance of the equipment in the food industry. Even they do the maintenance of that one. Nowadays, state of the art, you have, you can have 1,500, even 2,000 gearboxes, 2,000 pumps, 2,000 electrical motors. When you have this asset, now the maintenance becomes, very complex and complicated. So if that is the case, what is the best way that, augmented reality that even, when you look at the airplane pilots, because their dashboard, when you look at that, they have to switch so many things. Now, if you have an augmented reality, you will have the checklist, start having the paper format. Nowadays, they have like a tablet. So basically, it can walk you through that, you will have those glasses, the checklist is there, okay, turn on this, turn on this, turn on that, set this, set that. So basically, it will be prompting you and you are going. So that you can have, you can also create that, your maintenance, how to disassemble something, how to assemble something. Even already part of those things that can be from the ground for enterprise resource planning, you can basically upload the information there. And of course, artificial intelligence, I don't have to talk because that one is buzzword all over the place. Electrification, because of the electrical vehicles, that is becoming, interestingly that sometimes even the existing grids they cannot come because of the way, because there's common people who don't know that. In US, that Texas has a separate grid, and even the neighboring state, if it has a problem with power, and we cannot report that from Texas to that makes even within 100 feet, you cannot transfer the power because the grid structure is a little bit. So that's why sometimes, in different states, they have a little bit of variation in the grid structure. Even though power is available in one state, it will not be able to tap into where you be. So blockchain, that is again, it is becoming popular in the industry. They use that again also in the manufacturing. Look at the enterprise resource planning, that the data flows from the bottom to the top. That means you can give only access to certain people who, to whom it is relevant. So it is the same thing with blockchain using the cryptography. Basically, it is hiding the information. So if somebody wants to see some other information, it is not available. So that means you are controlling the levels of access to that information, but also you are making sure it is secure, that data. So again, the big data, these are all the ones here, sorry again that, you will not be able to read. I will give this, actually the presentation is there. I will also send it to, Dr. Shalom, so that, you can have that information that you, okay. So again, it is basically explaining Internet of Things, autonomous driving, what are the technologies, in all these areas. That's what it is giving the information here. So at the beginning, when I told you, from the 18th century to now, how we basically, the technology has progressed and everything. And also the automotive industry, as you can see. So this is the estimate. If it didn't happen today, it will happen tomorrow. So that is going to happen. So that's why don't believe somebody tells no, that is not possible. Everything is getting possible. Okay. So you look at the whole progress, especially for younger generation. That is the beauty. For us, we went through all the, even we didn't have all these technologies. You see, we survived, and also we are learning, we are educated now. When I went to school, I mean, there is nothing any of these technologies. But I have the choice either not to embrace that one. I will give you examples. In the United States, the medical doctors, whenever they, visit the patients, they used to write, there used to be a notepad about the visit details and, monitoring the health or progress of healing process. They used to document that one. Then suddenly, when tablets, tablets when they came, they gave them the tablets. In United States, doctors, they make very good money. Some doctors, basically, they told, heck with it, I'm going to do. See, they choose not to embrace the technology. Oh, it's all new, why I should learn all these new things, but I'm going to be that. They basically resigned and they left the profession. But that is a mistake. I know that, when we are old, the learning process takes a little bit longer. That is not that, just like a younger brain. But this technology is in our face. We will not have a choice. Whether you are young or old or whatever it is, you have to embrace it. And in a limited fashion, you don't have to know everything. So this is basically an example showing that, disruption will be there, but that's not a problem. We can move forward without any problem. And again, if you look at that, how many of you know that, how many components are there in a car? Any idea? Just a guess. Or an aircraft, or have you ever thought? If it's a bicycle, it is very simple, yeah? But I mean, you can say, okay, it has maybe, less than 25 or less than 30. Life is easy. You don't have car. It has 10,000 components, 10,000 parts. So of course, with this, 3D printing and the new emerging technologies and everything, and with the electrical vehicles down the road, you will see less number of parts. It may be reduced to, maybe 5,000. Look at electric vehicles, the whole engine block is taken out. So if that is the case, think about, how many components are there. Basically, you are reducing so many components. So the reason I'm telling A car has almost, roughly 10,000. Now it may be 9,000 or 8,000 because as technology is progressing, number of parts are getting decreased. And an aircraft has a million components, 1 million parts. Think about if you know a bolt and nut, that is not good enough. You have to have system level thinking with when you are looking at the subsystems. You see the hydraulics, the fluid handling, or exterior heat, because you look at the ergonomics, people they like the beauty of that, the aesthetics that you want to look at. And oops, oh, it is. Can you reduce that? Thank you. So it looks like it is very sensitive or static energy. So you see manufacturing, exhaust and emissions. When you have all these systems, so that means you have actually a foundation where you can leverage these technologies, how you can make it beginning when we told the convergence. And using the disruptive technologies, we can basically centralize and have all the information at one place and in the real time. Now, actually, in the manufacturing or whatever industry, they are talking about already, since several years, IT to OT. IT is information technology, OT is the operational technology. See, even artificial intelligence and machine learning and all these things, all the abilities to have data, they're basically, someplace they're analyzing that one and they're basically giving you the new information. Example, what is the connectivity between IT versus OT is, you take an example of a wind turbine. Wind turbine, when it's running, you are collecting the data, you know how much energy it is generating, what is the rotation of those blades and all that. Let us say the wind conditions change. If the wind conditions are changing, then suddenly there will be a change. So if that is the case, you see in real time, we're not able to do it. So if I find out the change immediately, using the data, analyzing the operational technology, can we change the parameters of the physical operation? It is the same thing. If you look at the automotive industry, you have the production lines, same chassis, different colors, different models. You can move through the different conveyor lines. And what happens is if one conveyor line, electrical motor, it is faulty, and that conveyor belt will come to a standstill. But the back end, still the chassis is coming. So if that is the case, how do I identify that one so we can route that one to a buffer zone or something? So the real-time variations immediately to fix the minimal impact. So again, as you can see that all these things, you have the opportunity to basically leverage that the new technologies just to show them. Now, when it comes to some of these, especially the automotive industry, they are looking at 4 areas. Some places they tell 5, some places they tell 8. But I think these 4 areas are very common. One is the electrification. We know that what is happening with the battery technology and all those things. And then you have the autonomous vehicles. And the autonomous thing, it is coming to everywhere. Now you heard about the advanced air mobility using the drones, and basically now to even to carry human beings, that basically the space that instead of the aircraft, basically you can have the advanced air mobility things. Drones are electrical vehicles basically flying, the vertical takeoff and horizontal movement. The same thing can be done within the cities, another thing. And you have the, when you have the autonomous, most of these cars they have the cameras. Please do not walk in front of the car. If you walk, because there is a criminal database, if it takes your picture, it is immediately transferring your location and everything to the police. Police know exactly where you are. So that means always walk behind the car. So that means you have only a criminal record. So that's what they started catching the people. knowing people were walking and the car basically jumped the face because it is scanning it face. You see, again, there is a problem of the privacy. Our information is alive and we have to. So we want to be very careful that when it comes to, connectivity is, that is the most important. You will be surprised. Even if you look at your CNC machine, machine controller, every controller is different. So that is the nightmare. The same CNC program, you have to have the conversion so the other controller can understand. It is the same thing with the programmable logical control. Even though the functionality is exactly the same, but they are not communicating, they are not. So that means if you have a programmable logical controller from one company, you have Siemens, you have the Allen Bradley, Mitsubishi, and all. But these devices, these programs, they don't communicate because they want to keep their profit and everything. That's why. But it can be nowadays you see the open source. They can make the open source, but if they do that, they lose the money. So see that connectivity and communication. Don't ever think if you have a sensor that if you plug it is going to communicate immediately. That's what you have seen in the cases. Plug has gradually now improved. And also, if you look at the USB cables, you have black color, white color, blue. But as common public would not care. So the color itself, the speed of that one, data transfer, another thing. So sometimes, if that communication and connectivity is not there, even though you can have your keyboard, it has a different speed and everything, then it will be a problem. You think you have the state of the art, PC or laptop, but the data transfer is not at the same speed. You see, the devil is in the detail. So we need to look at that one. Purpose-built, shared mobility, and again, as you can see, these are the technologies. Basically, that is also the quality as we are personalizing everything. Personalizing maybe the younger generation they want to have a different type of model. The middle age they want to have a different type of model. Old people they want to have a different type of it's just like you're in a race car industry. You think about the speed. Comfort, the safety is important, but comfort is not done. But if you want to look for a family car, you want to have comfort, so you can travel comfortably, but the speed is not the priority. So you see how these things will dictate. Also, remember one thing: if you gave your mom and dad to buy a new car and you ask them what about car you want, they will tell you the brand name, or they will tell you I want a good car. What do we mean by a good car? It is a fuzzy word. That's what it is. As engineers, we need to translate that word into the engineering term. Is it comfort? Is it aesthetics? Is it speed? What is it? Mom and dad, you need because when we know this specificity, then we can decide something, or we can look for that. So public always speaks generic terms. As engineers, we need to convert that generic terms into the engineering definitions or engineering parameters or technical parameters. If I don't know the speed, I don't know what to design. Because there is a big variation. You don't have a clue whether you need low speed or high speed that creates. So it's very important. And just to give you that some of the information that electrification, economy, connectivity, and purpose-built shared mobility, that is it is basically making personalized that what it is also they call it as a service utilization. So instead of buying a car, all I need to do is I can lease the car and use it. I will be charged for the miles that I'm done. Or in the educational systems, you have so many photocopy machines, or you have printers. So that means that is a capital intense because you have to invest a lot of money to buy that. And also when service life is over, again you have to buy them. You see how your money. So that's why nowadays companies, even photocopy machines, actually you can lease, they will do the service and everything. And you are here, biannually, whatever it is, you can renew the contract. You don't have to worry about that intense capital investment they want. So that's what it is happening down the road that, maybe, you don't have to build your own house. Somebody will break and, it's already there rented, but they have to control the rental prices. So again, once we know that, what are these technologies and how they are, good candidates for the automotive industry or any industry, all those things can be, applied anywhere. But the only thing is communication protocol will be different. Also, you need to look at the size and other things, when it comes to the technologies. And again, you know all these things, especially if they're into manufacturing. I don't know, it's clear, but not everywhere it should be the same. The trend is metal additive manufacturing and healthcare industry. And also, if you carefully look at most of the 3D printed, they're all single color. Or you can basically change few things to color, but in real world, it's a combination of different colors. So now they are thinking about the voxel. That voxel is basically you can create an object. So in the real world, it has different colors. The same component you can do. But we need to look at that. What is the purpose of that one? What is the use of that one? Or you are making earrings. Earrings have so many different colors, so many things. If that is the case, can you print the earring, incorporating all those colors in workshop? That will be it, because that is not done. But anyhow, with the 3D printing, 3D manufacturing, metal and the healthcare industry, and also just the 1 month back, I came to know that there is one company, young people, which is an icon company. They basically print the 3D printed homes and other things, and they have a special material, and they brought it to our company, our research institute, to test that material for globally and other things. The same company, actually currently they are using the lasers, use the dust on the surface of the moon, because you cannot carry these heavy materials to the space. It is very difficult. If you want to create infrastructure there, so they are testing using the laser how to fuse that material. So you can basically have a road or some kind of new infrastructure. So where you can do the your research or whatever it is, and that they are testing. And it is interesting to know that how they are trying to leveraging that even with dust on the surface of the moon to do these things. Now, you see, one thing I would like to that again here again analytics and cloud computing. Now you also heard about the edge computing. As you know, the sensors, when they are located at a distance, the data has to be transferred from that location to the central one, so that there can be a loss. Sometimes you will be surprised. You see, some of the sensors, they use, maybe 120 volts, or 24 or 36 volts. And then you have some, the digital ones, they use 0 to 5 volts. If you basically combine those two wires, even the electromagnetic interference will, basically there will be a loss of signal. If you look at, most of the electrons, they give the output as current. So again, you look at, most of the sensors, they have, it is not 0 to, the 20 milliamps. It is 4 to 20 milliamps. Think about what is the reason why they have 4 to 20 milliamps. Because if you have a 0, if the sensor fails, it is very difficult to find out it failed. But if you have the lower threshold as 4 milliamps, if it fails, then you know that if it is measuring 0, so that means it failed. So also we need to look at and we're looking at the functionality, what is the reasoning, why that is the only thing that is working, and all those things we need to look at. Yeah, here I was mentioning edge computing now basically partially they want to provide all the computing resource even at the sensor level. So that means sensor can only transfer the whatever the information your central thing needs, that information is you don't have to send the raw data and again at the central location basically doing the same function because sometimes loss of the information will be there when you are transferring this data. It will be delayed whenever you have control systems. You don't want to have the simple example. You use the control system, then you basically release the rocket. You want to make sure it is going straight. It's trying to hit like this. Then you want to send the control signal, so it will. Now, if there is a delay, what is going to happen is, you see, when it tilted a little bit more, even if you send the control signal, that only will do correction a little bit. Then it will go. See, that delay sometimes is going to create those problems. And the digital things that later on that with the augmented reality that has been beautiful, that using that digital things, and also that one thing I want to share with you, whenever you are doing the in olden days you have design analysis and then afterwards, you can build it and you can test it, validate, and release to the market. And later on, we got the simulation. Now, besides simulation, the new one is coming is emulation. Because simulation is only the model based. You are basically simulating that environment because you are not able to see the real world changes, everything happening. So that means now with the emulation, what the real physical device will do in the production. Example, automotive industry, if you look at the beginning of the their chassis toward the end of the line to see the part, and because there are so many sensors, so many things, assembly is happening, welding is happening, all these things when the chassis moves from the point A to point Z. So if there are any things, when you install the production line, you have to test the functionality of each and every sensor, each and every model, whatever the device you have. So now with the emulation, basically they are able to test it, like the real world simulation, that one, not a model based. And basically you take it to the floor, you have seen the robotics area, you basically create a program, take it to the location, you put it and it is ready to go. So that is another thing is coming with the emulation that you go beyond. So again, same information we already talked about that, I already mentioned to you about the servitization at the upper left-hand corner, what you are seeing, that is basically personalizing. So all these technologies and other things, that's what we are facilitating. One of the examples, even for your home, the water consumption or the power consumption. So basically you will have the history of that one. So next year you know how much you need to budget. At least if you want to readjust with cost of living, you can do that. At least you have some idea about what is going to cost you for the following year. Or one thing is the water consumption. Let us say for 2-3 months your consumption is more or less the same. But one day, 1 month you see the outlay, the consumption is more. So that means either there is something happening, you have more people visiting your home, or there is a leak which you cannot find out. So that gives you an indication that there is something wrong. So you can basically, troubleshoot the things based on that. So better driven it is, circular manufacturing or circular economy. Instead of, decommissioning the thing, we want to basically repurpose that one, recycle that one, and reuse that one. You heard about the 3 R's, and that one is, as a designers and manufacturers, you need to be basically taking into consideration. And I mentioned to you that it's a simulation, That one is a model based because you cannot predict the real world, all the variations in the real. Again, you look at machine installed at a certain level of sea level versus at a higher sea level, the performance will be different. There will be a pressure difference. It will not be the exactly same. So if that is the case, how it is going to that impact? We need to look at that. And again, those some of the ones is a repetition what we were in now. And just to give you the information now, artificial intelligence. Also think about this one. Machine learning, data science, and artificial intelligence. That is not your foundation. Your foundation, you have to have a physical device. If you don't have a physical device, artificial intelligence is useless. Simple thing. Think about it, you're buying an ice cream. It has a foundational flavor, but if you want to improve different flavors and other things, you can put some sprinkles and other things, different things to increase that. Similarly, whether it is machine learning or artificial intelligence, we are trying to improve the efficiency, improve the performance. But if you don't have the gap, foundational gap, but you cannot skip mechanical engineering thinking that artificial intelligence will do everything. That is not possible. You have to have a basic understanding. So again, looking at previously we talked about, see at the bottom right hand corner you have quality control. In olden days, quality control used to be a separate division. Now quality control is integrated at every step. It doesn't have to be a separate. It is the same thing. When you have emerging technologies, when you are collecting the data, you don't collect the data at the end. So that means each and every step in your company, you collect the data so that you will tell you the story if there is a variation or something, how you can fix those things. So again, that as you can see the Spark insurance, again based on the usage, that means you can negotiate your insurance rates and energy utility. It's very interesting. That I don't know whether you heard, but in the US, most of these petrol bunks, they don't want to install the charging station. So you see, when you buy the the petrol, you have a fixed price. You know it is 100 rupees, whether you buy it at midnight or early morning or daytime or peak time, it doesn't matter. Every time the rate is 100 rupees. But the electricity, I don't know here in India about this, but in the US, at the peak hours, the price is high. During night, when everybody is sleeping, the usage is low. Actually, that your kilowatt hour rate is low. See, there is a variation in the price. So that means now the customers, they don't know where to charge. Suddenly, they need their peak hour, that basically the charge price will be a lot more. See, the devil is in the detail. We think, wow, this is great. And still, they are struggling how to basically build the whole infrastructure for the starting the charging stations and other. And as you can see that the smart cities, you see there that V2X, that is basically V2P and V2I. Now they're basically combining those two. They're making it as VTX. Okay, it is same thing. VFX, designed for so many different. Design for sustainability, design for assembly, design for manufacturing. So all those variations. So instead of having different names, they are using conveniently that the letter X. So it gives unimaginable areas of whatever you want. And again, surveys and the dealerships. Again, nowadays, you have the synthetic oils, they are giving more light, especially not the electric vehicles, but the internal combustion engines. So that means your service, predictive maintenance can be estimated that one. Location intelligence, as I mentioned to you already, that as an individual, you are sharing the location with a new person you are going to meet. Hey, I'm here. So basically, the Google Map is going to walk you through the same technology. It can be used, between past years. Smart parking, as I told you that if the car is going to do everything, it is a tool or it is a toy. I use that one. And mapping and planning. See, this is what when I mentioned to you, you have the cameras on these electric vehicles and you have the LiDAR. LiDAR basically will create a point cloud and it will create the map of the terrain around the car. So that means you know exactly that, how to avoid good objects, object avoidance and all those things. That is, LiDAR basically is not actually from drones to the name that it is used. All you need is you want to plug the information, that map information, even with the drones that you have the LiDAR, but LiDARs, those are expensive. Those are really expensive that one has to. Fleet management, again, this way you know exactly where your car is located, where the location is there, right? Which driver is free, so that way you can send that information. I mean, Singapore, I think, maybe even 20, 30 years back, they had in the shipping lines, actually they had that fleet management. If you go with the package and you say, I want to send it to a different country, they go through the software and everything, immediately they will find what is the next ship, which is going in the direction where you can deliver that one. Singapore had fantastic automation, very advanced, unbelievable. That's what I used to tell my students for a long time in one of my courses, which we think they are new, but Singapore already has it. So again, visually, as I mentioned to you, hands-free, voice, music, and all these things. That voice activated, as I told you, that I can tell the car what to do and all those. As you can see, this is the beauty for all of you. You have, which we never had access to this one. You have these things at your fingertip, and also that at the extreme upper right hand corner, you see the LTE. Now, you have, 3G, 4G, 5G, that, they keep on adding those ones. So again, basically, that is the advancement for what is going on in those areas. So even if you look at the TVs, see, 2K, 4K, 8K, this is all fooling the public. I don't know how many of you think that is a great image. All they are doing is basically the same data. Basically, they are reducing the pixel size and it makes it look short. But beyond that one, there is nothing. And also, when you are collecting the data, and most of the sensors and other things, even images, you can collect the 12-bit data. But if you look at all the monitors we have, TVs, they're all 8-bit displays. They don't have the full capability. Still, we are not able to, even in the medical industry, that is the problem. You don't have, there are very few 10-bit monitors. All these monitors are only 8-bit. Even though you have the data at the 12-bit, you are not able to display it. Okay, so that's why I'm about the variations in that. If you think you have best data, but the thing is the next level when you want to analyze that or process that one, maybe the next system it doesn't have it. That's why in the medical industry, even if you look at the image format, that MRI has a different format, X-ray has a different format, and ultrasound has a different format. Even the breast cancer, when you do it, has a different format. You see, it's the same information, but it has a different format. Now you have to leverage all that information and use it as needed. So again, this is the beauty, basically, that as you can see that how everything is getting integrated. You will be driving multiple cars. Maybe I will be still driving my old car, which doesn't have the technology, but younger generation will be driving all these, So again, as I mentioned to you, if it did happen yesterday, that today it will happen. And also that there is only one person. He convinces the whole world what they don't need. He designed that one and he comes to the public. It is very difficult. Most of the things they come based on the need, based on the user feedback. Then we try to design and implement those ones. But this person today, most of you are using. He basically came up with the idea designed and built and convinced the public people. That is Steve Jobs. iPad, iPhone, and everything. I mean, look, iPad. In olden days, I mean, nobody thought, okay, with it. He designed and he convinced you. People, they bought it. They love it. So, again, as you can see, the personal computers, how they are going to change. In olden days, we used to have, mainframe. Actually, CNC program used to have a piece of paper. It used to have holes, the same CNC program. So now from there, change it to the tape. From tape, then you have floppy disk. From floppy disk to now USB stick, another thing. You see how the technology has moved. But interestingly, the tape is still best. Most of the secret service still they use the tape. I think even the movie industry also they use, because whenever you use the hard drive, if something goes wrong, the whole hard drive is unusable. But if you have a tape, only that portion you can cut it and you can join together, still you have the rest of the info. So secret service actually still they rely on the old technology, they don't want to lose that. So as you can see that again communications, now you have seen your mobile phones, year after year, how much power it is there inside them. It is amazing and fascinating to see that. Smartphone, now electrical vehicle. Basically, they are targeting by 2035 or 2050, the internal combustion is going to die. But I think, I personally, I will not immediately buy the electrical car. I will rather buy a hybrid. Because, even though there is technology to monitor the performance of the battery replacement, as you know, it is very expensive. And also, actually, the new business opportunity is recycling of those batteries. That is the era. Luckily, close to our university, Panasonic, they are actually putting a electric vehicle battery company. And they will be working with us. It is a $4 billion company making. Also, you need to be very careful. Young minds, if you have your own business, dealing with the big companies, don't think that is a great thing. If Tesla comes to you or talk to you, we are all excited. But those companies, they will dictate. We did projects for Tesla and others. People they told me, Raju, don't get excited. It is not what we tell them. They will tell you what they want. Because they have the money and they have the thing. So that means you need to be careful, even dealing with the big guys. Either they can make you rich or they will make you poor. Elon Musk, he will tell today, okay, I will give you buy millions of components today, and suddenly next year he will find another manufacturer at a lower price. You become like a curry pata, curry leaf, you use it and you discard and you are on the street. You want to be very careful with big companies. So again, some of the most of the games were with even with the battery technology nowadays, looking at the density and other thing and how they can improve that one, how can improve the performance and all those in different areas. As I mentioned, communication is a so it is a good thing. As a teacher, you can teach from morning to evening, but somebody has to come and cut it out. Exactly. So again, as you can see that different types of sensors and other thing. Again, think about when you want to use these gadgets. Look at the functionality. Look at the the usability and modularity and how you can manage. You can buy a very expensive, but you don't have the resources to maintain them. And if something happens, it will cost you a lot. So you have to be very careful, looking at very carefully each and everything, is important. And similarly, the software, as you have seen, the software industry, basically they are telling you don't need too many programmers, because there are people who will program it. If you are using the LabVIEW or MATLAB, it is like even data mining and other thing. Is you have the blocks basically you pull the blocks together and you connect them together, you can write the program and everything. So you have to be, programmer, even, they want to make it very easy. That's what is happening in the robotics industry, because they want to make it easy for the people who are on the shop floor who can program. Not even have an engineer or somebody else. They have to do it. So that way there is a little bit variation. Basically, the worker who is working with the robot, they can make those changes. The other thing is nowadays cybersecurity is becoming that is a major thing, because with all these technologies that has been focused, but cybersecurity, because spoofing and spying, basically stealing your data, even if you fly the drones, the data can be stolen. So you need to be very careful with those. And the data analytics, we talked about cloud computing, predictive analysis, that the regulatory thing, industry is moving so fast, and the government, they don't have time even to get together this kind of create the limitations for this. And at the end of the day, see the lot of collaboration. Even in the research areas, instead of one person is doing, it's all collaborative. Now, when it comes to the, again, you can see some of the digital transformation, how it happened with Tesla, Volvo, and similar way, BMW, and interestingly now Chinese, they came up with so many variations. But when you want to buy a vehicle, Chinese means you want to be very careful, especially with the battery life. Because Tesla they gave mostly 10 years warranty, but Chinese maybe 2 years or 4. So that means we will be changing a lot more. Chinese are very capable to change the labels. In front of you, they can, a 2-year warranty, they can change to 4. Until unless you have test facility, there is no way you can test. So again, when you are doing business, the Chinese you want to be careful. So again, that there are challenges, even though we said, even automation and all these technologies, if it works, life is easy. And if it doesn't work, it is a total nightmare. Even the automation. I don't know how many of you have ever thought, even at the airports, baggage handling, once you give your luggage check-in and everything, behind that, it is like, it's like snakes. Those conveyor belts, they move inside. They have to do the security check, routing these things, and checking all those. So it is amazing when you look at those technologies. Sometimes it's difficult, and also that we were not able to catch, train the people, provide the knowledge base. Still, across the board, we don't have subject matter expertise in all these new technologies. And cybersecurity, as I mentioned, that again, interoperability, that is the communication between the devices. I myself that I found, the load cell, thought, I can interface with the PLC. Talking to the application engineer, one guy he told me, yeah, you can do that, but it was not happening. When we found out the right guy, we told the printed circuit board when you have, even though you have Ethernet connection, it will not happen. Some of those ground level things, of course, just towards the end, you have that trends to watch with automotive. That is, of course, machine learning. Now with the chat GPT, another thing that is embedding, and also autonomous tasks, and similar way, electrification, zero emissions, and you will see at the top upper right hand corner that Mr. Ashokan, he told vision zero. Vision zero is everything will be zero, so the impact will be minimal. I don't know what kind of electric they will give. VC0 or VC2, version 2, version 4, or like that. So you will be seeing that. Okay? And as you can see, shared mobility, we already talked about buying and owning experience, digital transformation. That the CX means, now the customer experience, that is another. You have, CR, customer relations management, then how do you manage your customers and they are happy that that also to give you that, with all these changes in mobility and everything. So there, I will cut it out. It is just an overview. And again, I'm not the best subject matter expert, but at least that, I'm learning and I'm implementing those. Or, currently we are doing a project involving, it is a student design project with a utility company, identifying the defects with the insulators. When you look at the transmission lines, you have millions of lines of transmission lines. There you have this, ceramic insulators, they crack. And also, if you have a wooden poles, these woodpeckers, they make poles. That is creating a problem. It is weakening the strength of the pole. So when you have, how many of us every day want to climb a pole and find out how many poles are there? So basically, we are using the drones to take the images, and we are going to use that as a database to clean that one, send it to the machine learning to develop the model, and from machine learning to artificial intelligence. It is a basically multidisciplinary project where you have mechanical, electrical, computer science, and machine learning systems. Various students, they work on the project, and actually we are doing this for electric utility company. So that will be implemented by them. I mean, that's where we cannot access their data. They are giving access, but it is not letting. That's all I have. That So how many questions?
Yeah. Yesterday the data question. Yesterday. Autonomous vehicles are never going to feel. Our condition is not enough.
I think, partially that because autonomous vehicles, mostly because India, because of the sheer population, because when you see that and when you have variation, you don't see that kind of variation in the animal. So that's why but again, the manufacturing industry, we have AGVs, automated guided vehicles, to move the trains. Maybe we have the advanced air mobility that you can find all the population and basically on space that you have that. So that's why even we did a project using the drones. So usually whenever these things happen, it can be a domestic violence, a fight between husband or some, or there is a thing, or there is a on fire, or the vehicle. But what happens is whenever everybody goes from firefighters to cars to the whole battalion. But now, basically, immediately when we get the car, we basically fly the drone there. The drone will basically, about 200 feet. We found out most of the infrastructure we have below 200 feet. That level basically fly it. It will be moving against the location. It will be the kind of protection which one is. So similarly, the cameras breaking the top line, moving in the car. Now, I mean, we come to improving a lot of things are happening. That again, maybe next 10 years, what is not possible, maybe we have all the infrastructure. Everybody is following the guidelines that stop at the jungle line, the motorbikes, they go and sneak the air everywhere. So everybody is following the rules and regulations. Maybe that the
possible independent expressways.
yeah. I mean, you have the autonomous vehicles again. The type of plan you are doing. So that's where we think about when and where how to implement because it's a great technology that will go for it. But I think the end of the day, India has to because otherwise it will be left out.
Sir, how much percentage of that's being this?
Don't know the exact number, but I think, market says at this point, maybe, below 5% or something. Because initially the prices are very high, but now there are other variations are coming, so the prices came down, must also that they started increasing the price. People who bought it last year, they might be crying out loud, as within 1 months now.
The certificate is mostly on
Actually, yes, is a, even you have, that rugged equipment, for the harvesting, so it is said to be even big, where food coming from, especially in the small cities and other things, like San Francisco, because those trucks have to move from one location to other location. They already have electric vehicles. How many how many cars you have the electric buses? They are coming, city by city, sometimes actually working.
So the gradual change from
That's what the idea, but still, even the electric vehicle technology, when you look at the product life cycle management, we need to look at something, where you are harvesting the, how you are processing it, how you are making the decommissioning, how you are doing with it. Now, mobile phones, we have 100 million phones are decommissioned. It is a waste. Yeah, even that's why they are very, there are no country is working on the areas. Only China is doing, but unfortunately that is also very toxic way of doing, because to harvest those metals, chemical process what you use. Yeah, thank you. Chemical process what you are using, that is basically very toxic. Actually, in China, that they have a place. It looks like a toxic waste lake, and unfortunately, that if you want to have a lake, you want to make sure there are no underground stream of water. If it is there, basically now toxic materials, basically they are seeping into the underground water streams. That's why, example, in the nuclear industry, nuclear waste is only dumped where you have the salt mines. See, wherever you have a salt, it kills every living organism. So there is nothing underneath that. So even there is a leak, nothing is going to happen. So wherever you have a salt mine, you can dump those ones. But Chinese actually they are facing that. China went very rapidly, but now they are inheriting all the problems. If you go and see in Chinese factories, the pollution is so heavy. But is in US, they will close it in a split second. Motorbike, And also, it is very interesting in China that the production facility printed circuit boards, you have to put capacitors and resistors. There is a line of people sitting there. The printed circuit board moves from person to person. Think about 8 hours every day putting the resistor on a printed circuit board. Even testing that printed circuit board, basically you have the light. Under the light, you want to make sure that 8 hours per day as human beings. It is very difficult. That's where all these new technologies are going to help.
it's not being made. We can't get it, something like that. So how to get this data?
Okay, it's a very good question. See, again, you have to understand, family industry and other thing, it is there. Because if you are in business, you don't expect, they are not there for, 70 community 70 years, you are in business to make money. So that means if you have a competitive revenue, you want to keep it. So now one thing, what you can do is, sometimes the government specifically like the data, public information. That is one source you can get that. So if you have a right data, steady data. Yes. The data is and other parts, the with that situation, that's my question. When we were doing the project, we don't want to take one, but usually want to have trade secret just for minutes. We are going on. But the company asks us, who do you decide? Because they only want the ones we have for me to respect. We also we don't. I mean, answer the question. The other one is actually not this markets. And the big industries in the US, I don't know if it's something the market will the market has a clear now. This way, they will study the market. Only functionality of the market. And basically, starting off, design style, everything configuration, the department. So, finding this out, you can also find the product. You can find the pieces. It is very important and also very important. When it comes to this filing, some of the governments will be I think we have to go to the website, so you get government, you have all the government data, and you want the government, and actually they are reflecting what exactly you are doing. So sometimes, even though we think about the tribal data, you want to make whose data it is, otherwise actually you know that's fine and they are lost. So it's not everybody said. But I mean, big companies they spy everybody and all the other that you see if somebody is that's where actually still they are working on probably not very organized. And that's why they are as and we did somewhere even with these ones. Some companies they want to be so something people are only never got yes. Living comes I want to do the down. And yes, I want to know. Basically, look at this, have been never gets. So basically, self became an enemy. So, but because we have to have every 3 weeks, we want to 3 weeks, we want to security. So, the requirements, say, don't give up. Don't give up, even the similar I mean, you see, in the US, actually, some solve for the day. Sometimes we go companies. Okay. Again, this natural language. See, it's only like the answers. It's not a capture container. It is most of you use it. Sometimes people ask to take you there is no so you see that absolutely your problem. Because it is good and use it, not rely on the person. And I will follow the perspective of the privacy. Now it's very wrong information they want to have. Because humans, we are some people expect students, some students they learn, some students they will never learn. So the same thing will happen with the wrong children. They are clean. We just but in the the children get more the scenes will come so you see, even the side of the move on, we have to say something about the programs. We have to gather. So, but for you, that's like in beautiful, you have tools for the program, you have so something you have to so responsibility is yours.
Online participants, you have any doubts? If you want to clear your queries, please raise your query. Online participants, those who are attending through online mode, if you have any query, please raise your query. Professor is waiting for your call.
Yeah, it looks like I did a wonderful presentation. You don't have to first. So after all this, you said, thank you very much. I really appreciate it. Everything would be a job that having like friends and everybody and interacting with people. You know, technology is good, but you know, social interaction, there is no way to do this. Even that's what it is. Real world simulation is not. Even you're you know, just we can capture the real colors. See the difference. When I was capturing the data from the display.
Thank you, sir. Thanks a lot for your wonderful lecture. Had a good interactive session. My MTech student raised so many questions. You have clarified. Thank you, sir. From the bottom of my heart, on behalf of I personally thank you for providing a very wonderful lecture to enhance our knowledge in introduction to automotive. Thank you. So, token of appreciation, I would like to, sir, it was all wonderful.
You know, this is a job. One time we are dealing with the gold mining industry. We're testing their power. So I was expecting when we tested, we will find some gold. Wow, this is good.
Cell phone. And if you want to take cell phone.
Yeah. Some phones they are. Thank you very much. I really appreciate that. I will check someone that I will take this one. Okay. I will love this one. She's a very independent.
All vegetables.
Yeah. And what is the top of that? My wife should apply for it. But I just didn't know. This is all, but that's it. Thanks.
Very nice, sir.
Yeah, thank you very much. It's fun now.
Thank you, sir.
That's the thing. I really appreciate it.
Thank you, sir.
That's, you know, whenever you go to work, it's just a thing. You know, I use I have most of my students on Facebook. Whenever in their companies, they really see them there. So, that's all they do. So, then,
Is this your university campus?
yeah, this one is say that what we yeah. Because when they see that house state, everybody, they can then see that outside the state.
Friends, thanks for joining the meeting hall. Thank you. We will meet in some other occasion. Thank you.
Thank you very much. I appreciate it.